Now we will see the coefficient of fluctuation of energy. It is defined as as the ratio of the maximum fluctuation to the work done per cycle. Maximum fluctuation to the work done per cycle. Mathematical, the coefficient of fluctuation of energy, that is the maximum fluctuation of energy, that is E max minus E minimum divided by work done during the cycle. Work done during the cycle is denoted by given by E mean into theta. E mean is the mean torque available and theta is the angle turn in one complete revolution, which is given by 2 pi in case of steam engine and 2-stroke internal combustion engines, and 4 pi in case of 4-stroke engine. Okay, in a steam engine, the 2 pi, because after every cycle we get a power stroke, and the complete cycle is completed by one revolution of engine. Whereas in case of internal combustion engines, the theta is 4 pi because one cycle covers in 2 revolutions of crank. P mean is the mean torque, which can be calculated by the formula of power, that P is equals to 2 pi NT by 60. If I rearrange this formula for the calculations of mean torque, then mean torque is P by omega or P into 60 by 2 pi N, where P is the power transmitted in watt, N is the speed in RPMs, and omega is the value of angular speed, which is given by 2 pi N by 60. The work done per cycle may also be obtained by using the following relation. That means the work done is equals to power into 60 divided by N number of working strokes per minute. If N is the N in case of steam engine and 2-stroke, because number of revolutions per minute is equal to the number of working strokes. In case of 4-stroke engine, number of revolutions in 2 revolutions I get a single working stroke, therefore in N revolutions I get N by 2 working strokes per minute. So you can determine the value of work done per cycle using these 2 relations, either of these relations given. Now we will see the fluctuation of coefficient of fluctuation of speed. The difference between the maximum and minimum speed during a cycle is called as the maximum fluctuation of speed. So maximum fluctuation of speed equals to N max during a cycle minus N minimum during a cycle. Speed. The speed can also be expressed as radian per second, and the mean speed during a cycle is simply maximum plus minimum, the average of these 2 values, maximum plus minimum by 2. Okay, so this coefficient of fluctuation of speed is denoted by CS, and coefficient of fluctuation of energy is denoted by CE. Now the coefficient of fluctuation of energy, sorry, the maximum fluctuation of energy maximum fluctuation of speed, delta N. Similarly, coefficient of fluctuation of speed is delta N by N. N is the mean speed, is equal to N max minus N min divided by N max plus N minimum. Okay, you can also write in terms of omega, 2 times of omega max minus omega min divided by omega max plus omega min. Or you can also write it in terms of the tangential velocity, 2v max minus v min divided by v max plus mean, where v is the tangential velocity of the rotational component. Okay, these are the fluctuation of. Now next term, which is the reciprocal of coefficient of fluctuation of speed is coefficient of steadiness equals to 1 by, simply it is n mean speed divided by n max minus n mean, or n max plus n mean divided by 2 times of n max minus n. This is the coefficient of fluctuation of steadiness. Coefficient of steadiness basically. So in this manner, we can determine the fluctuation of speed and fluctuation of energy of leaving a flat. If you have any doubt or query related to this class or any topic of theory of machine, then send your doubts or queries on the mail IDs or the numbers given below. Thank you.